A main theorem in calculus is the mean value theorem for integrals. And an extension of that is the definition of the average value of a function on an interval. Here they're written in their calculus wording. And a lot of times students get overwhelmed with what these theorems mean. It feels like they're not reading English, they're not reading math, they're reading gibberish. So this video will try to debunk the meaning of this theorem and make it more interpretable or more digestible for each student. So the calculus wording is presented on the left, and my goal is to try and give you an interpretation. So I'm going to try and spin this into a more visual idea. And for me, I think of a tidal wave pool. And I have duckies on a tidal wave pool. And as this tidal wave pool sloshes back and forth, it's going to slowly calm down. And when it calms down, it's going to calm down to a uniform calm height. So as a picture here, I have this tidal wave, which is has some small waves on the left and some big waves on the right. And as that tidal wave calms down, you notice these duckies are, some of them are rising, some of them are falling, and some of them are staying at the same spot. Okay? On this visual, I want you guys to think of this as your average value. And there are these green duckies that aren't moving. And the reason they're not moving is they're already at the average value. So I can guarantee there's going to be at least one ducky that never has to rise or never has to fall down to the average value. These duckies here, they're rising to the average value. And these duckies here are falling to the average value. But the green duckies are already there. So the mean value theorem and the definition of the average value, to me, I'm going to take it and interpret it as part of a tidal wave pool with duckies on the surface, and some rise, some fall, and some stay at the average value always. So we're going to look at this problem here. It says find the average value of sine x on the interval 0 to 2 pi. This is the most common way to see it worded in a calculus book. And I'm going to interpret it as, what is the height of the tidal wave when the water calms down? We're going to take a look at this on Desmos. Right now I already have sine x from 0 to 2 pi graphed. I already have duckies shown. And I'm going to try to interpret finding the average value by saying, what is the height of the calm water? Now as I scroll through this continuum, my purple water is calming down to there. And it should make sense that it calms down to 0 because I have this mound on top of the x-axis, which should be canceling out the negative area below the x-axis. So again, if we start from the original, as the water calms down, some yellow duckies fall, some yellow duckies rise, and there are 3 green duckies that stay at 0 because that's where they started at. We're going to look at the math behind what I tried to reveal to you on Desmos. So on this problem, the first thing you're going to want to do is find the total amount of water. That total amount of water consists of this positive region and this negative region. Now visually you should see that by symmetry the top region has the same amount of value as the bottom region, just one is positive and one is negative. So if they're equal amounts, that should add up to 0, but I want to show that to you in an integral. So we're to find the total amount, we're going to take the integral from 0 to 2 pi of sine x dx. And the integral of sine x is negative cosine x from 0 to 2 pi. So you're going to get negative cosine of 2 pi minus cosine of 0, which equals a negative 1 minus 1, which does cancel out to 0. And I want you to remember that that 0 is the total amount of water. I have not solved for the average value yet. I just found the total amount of water is 0. To find the average value, think through the animation again. If this was the original surface of the water, some above and some below ground level, as it starts to calm down, I still have to have a net amount of 0 water, which means the end result is 0 for the average value. It has to calm down to 0. On the next example, we'll look at one that does not calm down to 0. The question in calculus, find the average value of 1/3 of x squared on the interval 0 to 3. My interpretation, what is the height of the tidal wave when the water calms down? We're going to look at Desmos again. I have 1/3 x squared graphed. I have some duckies shown. And as I play through the calming of the tidal wave, the left ducky rises, the right ducky falls, and there is one green ducky that is already at the average value. And our goal through paper and pencil is to solve for that average value. So let's take a look at that. So I have shown there the picture of the tidal wave as it starts. And our first goal is we're going to find the total amount of water. So to find that, we look at the integral from 0 to 3, 1/3 x squared dx. That integral becomes 1/9 x cubed from 0 to 3, which equals 1/9 of 27 minus 0, which equals 3. Now that, again, is the total amount of water. We have not found the average value yet. We've just found what this blue region is worth. To find that average value, the water, when it calms down, it's going to calm down to a uniform height. That means it's going to calm down to a rectangle looking shape where everything has a uniform height right there of the average value. Geometrically, I need my green rectangle to equal the blue shaded region. Well, I know the blue shaded region is worth 3. And I know the area of a rectangle is length times height. That length is from the right bound of 3 to the left bound of 0. That width is 3. So I have it as the total amount of water is 3. I know the length is 3, and I'm trying to find the height. So when you solve that and you divide both sides by 3, you get the height of that rectangle being 1. That height of 1 is the average value. So when it says find the average value of 1/3 x squared on the interval 0 to 3, it is 1. An extension question would be find the values of x in the interval for which the function equals its average value. This question is saying what duck or duckies, it can be multiple, never move up or down when the water calms down. I'm looking for the green duck. Where is that green duck? To do that, you know the function. The function itself is 1/3 x squared, and we found the average value is 1. So my goal is to say what x gets me an average value of 1. When you solve that, you can multiply by 3. X squared equals 3. If you square root that, x equals the square root of 3. That is the location of the ducky right here. That is the location of the ducky where it never moved up or down.